All right, so what's going on, Yelani? FEA is up next. Now, this one, I don't know if you're going to take it. This is what I'm doing my master's in. I really like this stuff. I like structural analysis. There's a lot of theory behind it. Well, actually, not too much, but I don't know how to explain it, but this subject is just pretty cool. That's what I do at work. Well, by the time you're seeing this video, that's what I'll be doing at work. So problem reads, obtain the global stiffness matrix of the assemblage by superimposing the stiffness matrices of the individual springs. So K1, K2, and K3 are not given. It's going to make the problem hell. You'll see why. Part B, if nodes 1 and 2 are fixed and force P acts on node 4. In the positive x direction, we got to find the expression for displacements of nodes 3 and 4. And then finally, Part C, determine the reaction forces at nodes 1 and 2. So let's go ahead and get started with this course. All right, so the overall goal for these FEA problems is finding this right here. So let's go ahead and label this step 1. This is the main goal. And you probably don't understand what this means, but that's cool. It's the force vector is equal to the stiffness matrix times the displacement vector. So so the first step in these problems is usually find K. Then once you find your K, you could kind of lay out this whole equation. Then you have to find your U's or your displacements, and then you can find your forces after. So that's how I notice they usually go, if I remember correctly, but either way, each problem will go one by one. So again, now let's look at the problem itself, right? So we got a node here. I'm sure you could read that. That's 1. This is node 3, node 4, and node 2. So there's 4 nodes total. That means this right here is going to be a 4 by 4 matrix. All right. So we got 3 springs. In this case, they don't give us numbers. So this is why the problem is going to be very long, because you got to put everything in terms of something. But like I said, if you know how to do this one, you'll be fine. What else? So we got K1, K2, K3. They don't give us the values again. That's fine. What else? Seems like we're good. So we'll go ahead and do the, oh, that's right. So problem A, first part. It says we gotta obtain the global stiffness matrix, which is the 4x4, using the little matrices. That's what I call them. So this is gonna have a little matrix. This one's gonna have a little matrix. This one's gonna have a little matrix. So you'll see. Look, let's see 2. Let's do K1 first, and this is part A. K1 is equal to. All right. So check this out. We're between node 1 and 3. So, and then, so it's going to be 1, 1. This is going to be 1, 3. This is going to be 3, 1. Ooh. And this one right here is going to be 3, 3. So let me just go ahead and do this. So the way I remember them, it's that drink RC Cola, right? Row column. So it's a row. The first number is a row. Second number is a column. So check this out. First one is K11. So K11, K13, right? I'm just labeling them up like this. And that really is all it is. So it's from node 1, not from node 1, I'm sorry. Row 1, column 1, that's K1, if that makes sense. Then from right here, we got K1, K3, K3, K1, and K3, 3. So that's a little confusing, I know, but just hang on, okay? So that means, and then this is the case for all of them. So it's K1, negative K1, negative K1, and K1. Cool. So that's kind of what it is right there. So this is telling me, again, this one's the case for all the what do you call them? The springs, the Ks. You're gonna have a positive, positive, negative, negative. And then this just tells you in what row and column that these will be in the 4x4. Okay, so now let's go to the next one. Again, it'll make more sense as we go through. Like, I really can't explain it. So the next one is this stiffness, this spring right here, and it's between 3 and 4. So it's K3, 4, right? And then we got K, oh, I'm sorry, messed up. Same thing, if you ever get mixed up, start it off again, my bad. So it's K, and it's 3 and 4. 2 nodes, right? So this is 3, 3, this is gonna be 3, 4, this is gonna be 4, 3, and this is gonna be 4, 4. I hope this makes sense, but so this is K3, 3, K3, 4. Let me make this bigger. This is K, oh wow. This is K3, 4. This right here is K4, 3. This one is K4, 4. And again, we're dealing with the second spring. So it's K2, negative K2, negative K2, K2. And finally, the third one. Again, I'm trying not to write these numbers here so I won't confuse you, but it's between 4 and 2, okay? So that means the first one is K4, 4. Next one is K4, 2. Again, it's row column. That's how I know 4 is here and 4 is here. They both start with 4 because it's RC, remember. And then K2, 4, K2, 2. And that is equal to, again, K3, negative K3, negative K3, and K3. All right, cool. So now that we get, we did all the, I call them mini matrices for the springs. Now we could assemble them all into one huge matrix. So it's gonna be like this. All of these, it's K is equal to this step 3. Global stiffness matrix. I'm just write global. All right, so it's gonna be a big matrix. And I like to make them pretty big, you know, just to make sure I have enough room. I really don't care about the waste of paper. But again, they're rows and columns. So that's first row, second row, third row, fourth row. And that right here, let's go ahead and do 1. Let's go ahead and do 2, 3, and 4. All right, cool. So this is position K11. This is position K1. I don't want to write on it, but this one right here is K11. This one right here is K12. This one is K21. Again, it's always row first and then column. So look, let's do the first one. So we got K11, K13, K31, K33. So that means it's this spot right here, this spot right here, this spot right here, right? K31, and then K33 is this one right here. So that means those are the 4 spots that this matrix is going to take up. So K11, we just got K1. Cool. K1. K13, we have negative K1. So it's, let me go ahead and erase these right here. So K13, again, row 1, column 3 is negative K1. It's that one right here. What else? What else? We got K31. That one is negative K1. So negative K1. And we have K33, we have a K1. So a K33, there's a K1. Cool. So K2 now. Again, this one is from nodes 3 to 4. So we're going to have the space K33, K34. Oh, I'm sorry. Hold on. K33 is this one. K34 is this one. K43 is this one, and K44 is this one. Cool. So K33 has K2, and it's a positive. So K33 shares this one, so we're gonna add them, right? Because we already had a K1 here from K33, but now we have K33 again. So we got that. Negative K2 at K34, negative K2 at K34, then we got negative K2 at K43. Okay, and then K44, which is this spot, has a positive K2. And I like to give myself some room just in case I gotta add again. But yeah, that's pretty much it. Now the last one, we got K44, we have a K3. So plus K3, see what I mean? At K42, which is this spot, we have a negative K3. At K24, which is this spot, we have a negative K3. And at K22, which is this spot right here, we have a positive K3. Cool. So that is your global stiffness matrix. Wherever you didn't have anything, just throw in a 0, 0, 0, 0, 0. And that's pretty much the answer to A. I would box it, but it's too damn big. Again, this would be a lot easier if we had numbers like 100 Newton per meter for a spring, and then you just add them up. But in this case, there's a lot of variables, so just hang in there. So cool, that's the answer right there. So now that we have the global stiffness matrix, we can make the equation. All right, so step 4. Again, problem part B says if nodes 1 and 2 are fixed and the force P is acting at node 4 right here in the positive x direction, find an expression for the displacements of nodes 3 and 4. So that means they're just looking for U3 and U4. Now, that's pretty long, but let's see. All right, let's see if you don't get lost. Okay, so I'm gonna go ahead and label the forces, right? It's the force vector, force at node 1, force at node 2, force at node 3, force at node 4. Now I'm gonna go ahead and erase some of these right here. You'll see what I mean. That's gonna be equal to the stiffness matrix, right? Again, this is the formula we're doing. That stiffness matrix is K1, 0, negative K1, 0. That's 0, K3, 0, negative K3. Negative K1, 0, K1 plus K2, negative K2. Then we got, let me write this one first, K2 plus K3, negative K2, negative K3, and 0. All right, so I just rewrote this, right? And then the vector. So it's U1, U2, U3, U4. And it's pretty much physics. Remember, force is equal to Kx. That's all it is, but just on crack, pretty much. Okay, so look, this is your boundaries. Now you gotta identify your boundaries. This you should know how to do. It's not really, and it's pretty easy to know. It's just, you're not gonna get nowhere without knowing what to do next, obviously, but you need to know what's 0 here and what's 0 here. So look, U1, there's a force at this node. So imagine there's like a string, right? And you're pulling from the middle of the string or close to the center. This is fixed and this is fixed. Point 1 and 2 are fixed. So no matter how much force you put, this will never move. So U1 is equal to 0 and U2 is equal to 0. So just like that, we knocked those two out. That's what I meant by erasing. Forces. If you pull here, you're gonna have a force here, right? At point 1, there's gonna be a force trying to kind of counteract this force. And then at force 2, there's going to be a force pushing towards the force because, right, it's just Newton's law. So that means, and then there's no force at 3. This was just like right in the center. It's just going whatever way this one chooses or these two choose, right? So cool. That means force of 3 is 0, right? Because there's nothing at that node that's going on. And F of 4, I'm going to label that P. That's just because I named it P. Cool. So that's pretty much it. Now we can form the equations. So look, check this out. First force, it's, let me label this part B, and label this step 5. I'm going to a new step. So force of 1x is equal to K1 times 0 is 0. Then 0, okay, so look, I'm going to put it with the pencil just in case you really can't see. So it's K1 times this one, the first one, is 0. Plus 0 times 0, plus another 0. Plus negative K1 times U3, that's going to give you a negative K1 U3 plus 0 times U4. Okay, so that's it, plus 0. Do the same for all of them, F2x. So it's 0 times 0, that's 0. K3 times 0, that's 0. 0 times U3, that is 0. Negative K3 times U4. Negative K3, yeah. Minus K3 times U4. Okay, cool. Damn, it's hot. So next one, 0, right? Because it's not F3x, it's 0. 0 is equal to negative K1 times 0, so it's 0. Plus 0 times 0, which is 0. K1 plus K2 times U3, so let's go ahead and do that. K1 plus K2 times, let's put plus here, plus U3 minus K2 times U4. Minus K2 times U4. Again, for P, we got 0 times 0, negative K3 times 0, negative K2 times U3, so it's 0 plus 0 minus K2 times U3 plus K2 plus K3 U4. Okay, K2 plus K3 times U4. All right, so let's focus more. They're looking for the displacements at nodes U3 and U4. So we are going to have to focus on these two right here because we can't really do anything here. This is assuming that we have a value for P, FYI. So that's why we could do this one because technically, yeah, it's an unknown, but not really. Does that make sense? Because in any other problem, we would have had P. In this one, because they want us to solve in terms of variables, they don't give it to us, but technically this is a known. So right here you have two equations, two unknowns, U3 and U4. And again, we should know K2 and K3, but they want it in terms of variables. It makes it a bigger headache. So we stick with these two equations. That means, let me go ahead and do this. 0 is equal to, it's going to be K1U3 plus K2U3, I just distributed, minus K2U4. This one's going to be P is equal to, let me go ahead, yeah, leave it like that. Negative K2U3 plus K2U4 plus K3U4, right? Let me go ahead and cloud this up. All right, whatever. All right, so step 6. Again, we have two equations, two unknowns. We want to solve U3 in terms of all the K's and P's, and then solve for U4 in terms of all the K's and P's. So it's pretty easy, look. We use the, let's use the first equation. Let's move K2U4 over here, then divide everything by K2. That should give us U4, right, in terms of K. And again, it'll be so much easier if we had numbers, but like I said, if you know how to do this one, you'll be all right. So it's K2 U4 is equal to K1 U3 plus K2 U3. That means U4 is equal to K1 U3 plus K2 U3 all over K2. Okay, so that's U4. Now what we're gonna do is we're gonna plug this U4 into one of the equations to solve for U3. And that should get rid of all the U4s, and it should leave us with K's and P's alone. So let's go ahead and use the second equation. Okay, so, well, actually, you know what? No, I'm sorry, that's wrong. Now we do the same thing, but for this equation. We solve for U4. So P, I'm gonna move K2, U3 over here, okay? Let's go ahead and do that. So P is equal to negative K2 U3. Again, my bad. So we solve for U4. Now we got to solve for this U4. And then we set those two U4s equal to each other. And that should give us, we could solve for U3 after that because we canceled all the U4s. All right. So, oh, snap, I didn't move it. Plus, right, it became a plus if you move it to the other side. So P plus K2U3 is equal to K2U4 plus K3U4. Factor out the U4, you get K2 plus K3U4. And then solve for U4, you will get K2 plus K3 at the bottom. P plus K2U3. Cool. So we got this U4. All right, now we set these two equal to each other. I don't want to rewrite these, so I'll just do it right here. Squeeze it in, okay? That's gonna be, set them equal to each other, you'll get K1U3 plus K2U3 over K2 is equal to K1U3 plus K2U3 all over K2. Okay, so let's see what we could do. We got, well, actually, hold on, that can't be right. K1U, oh, no, I set the same ones equal to each other. My bad. So K1U3, K2U3 over K2, that's that one, and then we set it equal to this one. So P plus K2U3 over K2 plus K3. All right, not too bad. Okay, now this is just math right here, right? Algebra. Multiply K2 plus K3 to this side, multiply K2 to this side, you will get PK2, right? Plus K2 squared U3 is equal to, I'm not gonna put the parentheses times this, I'm just gonna go ahead and do it. It's the FOIL method. K2 times all of this plus K3 times all of this. So you'll get K1 K2 U3 plus K2 squared U3, now the other one, plus K1 K3 U3 plus K2 K3 U3. Cool. So I see these cancel out, and that one and that one. Perfect. Let's keep going. We got PK2, PK2. They canceled out. So equals K1, K2, U3, K1, K2, U3. Double check this, I'm not showing you right. K1, K3, U3. Plus K2, K3, U3. Cool. So that's where we're at now. We could factor out the U3 from top right here. So we'll get PK2 is equal to K1, K2 plus K1, K3 plus K2, K3, U3. That means U3 is equal to all of that, which is K1, K2 plus K1, K3 plus K2, K3 all over PK2. Let me go to verify that's the answer. PK2, whoa, did something wrong. Damn it. It's the inverse. So they should have been at the bottom. So, but yeah, we did it right. I just got confused there for a second. But yeah, so it's, damn it, K1, K2 plus K1, K3. That's why I hate these damn problems, the variable problems. Once we start plugging in numbers, hopefully the videos won't be as long, but there we go. That's the answer. All right, so now we do the same exact thing, but for U3 now. So let me go ahead and write the problems again. Well, actually, I won't rewrite them. So look, check this out. Now we got to solve for U3. Same as, you know how we right here, we solve for U4s, set them equal to each other. Now we solve for U3s and set them equal to each other. So this is K1 plus K2. Check this out. It's this equation right here. Okay, so check this out. I'm just going to rewrite them. Whatever. These are the equations. 0 is equal to, this is K1 plus K2, so times U3. So it's K1 plus K2 times U3. And then minus K2 U4. Minus K2 U4. And then the other one is negative K2 U3. Negative K2 U3 plus, I'm going to factor it out again, K2 plus K3 U4. K2 plus K3 U4. All right, so next step, right, solve for U3. Let's go ahead and label this step number 8. All right, so move K2 U4 this way, right? K2 U4 is equal to K1 plus K2 U3. That means U3 is equal to K2 U4 plus K1 plus K2 over K1 plus K2. So that's U3 for this one, for the first one, for that one right there. Now let's do it for the second one, for the P1, step 9. Now we got, we're solving for U3. That means we could, what could we do? Yeah, we'll move this one this way and then P to the other side. So it's K2 U3 is equal to K2 plus K3 U4 minus P. Solve for U3. U3 is equal to all this. K2 plus K3 U4 minus P all over K2. All right. Cool. So we got that. Set them equal to each other, just like we did with U4s. We got K2U4 all over K1 plus K2, right? This one is equal to, let's do the top first, K2 plus K3 U4 minus P all over K2. All right, damn, it's just long. Let's go ahead and, it's a little complicated here. Okay, so let's go ahead and do this one first. Get rid of the K2, so it becomes K2 squared, right? U4 all over K1 plus K2. Don't worry, this is the longest part of the problem. Equals the top. So let's go ahead and get rid of those parentheses. K2U4 plus K3U4 minus P. All right, and finally, we're gonna multiply K1 to all of these three, and then add K2 times all of these three, just like FOIL, right? So it becomes, let's go ahead and move it here, right? It becomes K2 squared U4, right? This one. So now it's equal to K1 times this plus K1 times this plus K1 times this. That's gonna be K1 K2 U4 plus K1 K3 U4 minus PK1. Then the same thing now for K2. So it becomes K2 squared U4, right? Then K2 times this one, which is plus K2 K3 U4 minus PK2. All right, we're almost there. This cancels out with this. We want to solve for U4. So we want to get, this term has U4, this term has U4, and this one has U4. So let's move the P's on this side, okay? That way we're gonna leave U4 by itself, and then none of these have U4. And this is 0. So it becomes PK1 plus PK2 equals, I'm gonna factor out the U4. Okay, you gotta be able to see this just to save time. It's gonna be K1 K2 plus K1 K3 plus K2 K3 U4. Okay, I did like 2 steps, 3 steps. I don't even know how much steps I did with this, but these canceled out, move the P's to this side, and then the last 3 terms I factor out the U4. Cool, so we solved for U4 finally. That is, I don't want to confuse myself this time. If we put this, yeah, P's on top. So P, K1 plus K2, right? I just factored out the P. And then the bottom is K1, K2 plus K1, K3 plus K2, K3. Again, this is the sucky part about theoretical problems when they don't give you values. But cool, we found U3 and U4. That's it. So now part C, determine the reaction forces at node 1 and 2. So now that we have U3 and U4, now we could find F1x, F2x. So I'm gonna write these equations on the other side. Just step 11. F1x is equal to 0, 0, negative k1u3, negative k1u3. Similarly, for f2x, we are just left with negative k3u4, right? Because 0, 0, 0. We know u4, we know u3. Ideally, these would be numbers, but they want to make our lives miserable. So f1x, it's literally just all this and add a negative k1. So I have to rewrite this k1, k2 plus k1, k3. I'm just copying this. Okay, so I don't know if you could see, but k1, k2, k1, k3, k2, k3. Okay, and then p, there we go. So it's going to be p k2 times negative k1. Boom, that's the answer. So I do remember that finding u's, even though in this case it's very long because of the variables, even in the tests, u is the longest process. So the forces at the end, pretty easy. And f2x, that is just this right here, and then just add a negative k3 to it. So it's p negative k3 k1 plus k2 over k1 k2 plus k2 k3 whatever plus k1 k3. And that is the answer for F2. Now again, I've been saying it all video, but this is the longest problem just because they don't give us numbers. The stiffness matrix, I hope this kind of makes sense now to you. It's between nodes 1 and 3, which is why I know it's going to be row 1. It's going to be 1 and 3 and 1 and 3. So 1, 1, 1, 3, 3, 1, 3, 3. It always starts with this one, obviously. So if there was a 3 here and a 1 here, it'll be K33, K31, K13, K11. It all depends how they lay out the nodes. I don't know why they wouldn't just put 1, 2, 3, 4. And it's kind of cool when they do that because this is, if it's a 1, 2, that means it's this little matrix. If it's a 2, 3, that means it's this little matrix. And it's 3, 4, it's this little matrix. But because they kind of messed with us, 1, 3, 4, 2, it was these numbers right here, and then 3, 4, which was this matrix here, and then 4, 2, which was like a backwards kind of matrix. But it's still this one, this one, this one, this one. Again, I just want to let you know, FEA, it's I don't know how to explain it, but if you know how to do this, you'll get by through the whole class. FEA is really, really, really easy. Don't overthink it. Just follow the process. You'll be all right. But once we start getting into like heat transfer and all that good stuff, it's still the same thing. I don't know how to explain it, but it's the same thing all around. But yep, that's the answer to part A right here. This K matrix. Answer to part B is these two U's, U3 and U4. And then part C, F1 and 2. But good luck.